Britain had a working jet engine in 1937. Germany flew the world's first jet aircraft in 1939. America had no comparable working turbojet program, and World War II was already underway. Within 5 years, a small, secret team in a Massachusetts factory took a borrowed British design, rebuilt it from the ground up, and put the United States into the sky under jet power. This is the story of the Hush Hush Boys, and how a country that didn't invent the jet engine became the one that industrialized it. Stick around, because the real achievement here wasn't the invention. It was the 6 months it took to turn one borrowed engine into something America could actually build. Frank Whittle was a young Royal Air Force officer with an idea nobody in Britain's government wanted to fund. Instead of a propeller pulling an aircraft forward, air would be compressed, fuel burned inside it, and the resulting gases blasted backward at enormous speed. In 1930, Whittle filed a patent application for the concept. It was granted in 1932. For years, British support remained limited. Whittle refused to let it die. With outside financial backing, he helped found Powerjets Limited to keep the project alive. On April 12, 1937, his engine ran successfully in a test cell for the first time. It wasn't smooth or easy. It proved something the British government had doubted for years. A gas turbine could generate real propulsion. Whittle wasn't working in isolation, even if he didn't know it. In Germany, physicist Hans von Ohain was developing his own turbojet completely independently. His HES-1 engine ran successfully in early 1937. An improved version followed. On August 27, 1939, that engine powered the Heinkel HE-178 into the air, the world's first jet-powered flight. 2 countries, 2 independent teams. Neither one was the United States. In May 1941, the British Gloster E-28/39, fitted with Whittle's turbojet, took to the air. Watching closely was U.S. Army Air Corps General Henry Hap Arnold. He recognized its military potential and moved quickly. America had a problem. The technology existed and it worked. The United States had no comparable program of its own. Arnold went home determined to change that, and fast. Moving a jet engine across an ocean during wartime wasn't a simple shipment. Arnold arranged for Britain to quietly hand over Whittle's technology, an early W-1X engine, and drawings for the more advanced W-2B. The engine was flown from Britain to the United States aboard a B-24 Liberator bomber, arriving at General Electric's supercharger department in Lynn, Massachusetts on October 1, 1941. Having the physical engine in the building solved nothing by itself. Possessing a revolutionary British machine and actually manufacturing one in America were 2 entirely different problems. Britain wasn't handing over a finished product ready for an assembly line. It was handing over a handmade, one-off prototype built to prove a concept, not something built for mass reproduction by workers who had never seen anything like it. Everything from the materials to the tolerances would need to be reworked before this engine could exist anywhere outside a single test cell. The choice of GE wasn't obvious at first glance, but it made sense once you look closer. The major piston engine manufacturers, Pratt & Whitney and Wright Aeronautical, were already heavily committed to wartime piston engine production. GE's Lynn operation, by contrast, had years of experience with turbo superchargers, compressors, and high-speed turbine machinery, the same underlying problems a jet engine had to solve. GE wasn't starting from nothing. It already understood most of the physics involved. At the Lynn plant, GE pulled together a small, hand-picked team for a project shrouded in secrecy. Colleagues called them the Hush Hush Boys. They had the W-1X engine in front of them, drawings for the W-2B, and one enormous problem: make this design work with American manufacturing methods and materials. This wasn't a copying job. The team redesigned components, tested new configurations, and strengthened weak points across the engine, introducing a stronger impeller, an automatic control system, and improved turbine blade alloys. Behind the main production building sat a secret concrete test bunker the team nicknamed Fort Knox. Inside the engine, the sequence sounds simple. Air enters, a compressor squeezes it, fuel burns, hot gas spins a turbine, and the exhaust rushes out the back to produce thrust. Keeping that sequence alive under real operating conditions was brutally hard. The engine used a single-stage centrifugal compressor with a two-sided impeller, 10 reverse-flow combustion chambers, and a single-stage axial turbine. Temperatures inside ran high enough to destroy ordinary metals. Rotating parts had to stay balanced at speeds that would tear apart anything slightly out of tolerance. None of these problems had obvious solutions sitting in a textbook. The turbine blades faced extreme temperatures, so the team had to improve and test the alloys and materials used throughout the engine, often discovering a material's limits only by watching it fail. This wasn't an imported engine sitting in an American factory anymore. It was being rebuilt into something new. On March 18, 1942, GE's first experimental engine, the Type 1, ran successfully at Lynn. It wasn't yet the final design. Engineers kept refining it, and on April 18, 1942, the improved IA engine ran inside the Fort Knox test cell. GE rated the IA at 1,250 pounds of thrust. A machine that fit inside one small factory building had just given America a working jet engine for the first time. In June 1942, Frank Whittle himself arrived in the United States and spent weeks at the Lynn facility, working alongside the engineers who had rebuilt his design. The man whose drawings had crossed the Atlantic was now standing inside the American factory that had reshaped his idea. By this point, the Hush Hush boys weren't just reproducing his machine anymore. They'd redesigned enough of it that the engine had become something distinctly its own. An engine running in a test cell only proved so much. It needed an aircraft. The Army Air Corps turned to Bell Aircraft, where designer Larry Bell's team built a new airframe around GE's engines. The XP-59A Airacomet fitted with two IA turbojets. Secrecy followed the aircraft as closely as it had followed the engine, with the entire program classified well beyond what an ordinary fighter development effort would have required. In early October 1942, the program moved to Muroc Dry Lake in California for the privacy the military needed, and the XP-59A finally took to the air, with test pilot Robert Stanley at the controls. An American aircraft had flown without a propeller for the first time. The XP-59A wasn't the fighter anyone had hoped for. Its performance was disappointing, especially compared with the piston engine fighters already in service, and the IA never delivered the power later jets would reach. The first flight wasn't a finish line, it was a new starting point, a flying testbed engineers could use to find problems, redesign, and try again. The IA became the ancestor of a rapidly expanding family. The J-33 followed, reaching 4,000 pounds of thrust, more than 3 times the IA's output within just a few years. Then came the J-35, GE's first engine to use an axial flow compressor instead of a centrifugal one. By 1948, the J-47 pushed output to roughly 5,000 pounds of thrust and became one of the defining American jet engines of the post-war era. What the American jet engine teaches you. Lesson 1. Possessing the technology and being able to build it are two different problems. America had Whittle's actual engine sitting in a Massachusetts factory in October 1941. That solved almost nothing on its own. The real work was making it survivable in mass production. Lesson 2. Secrecy and speed aren't opposites. The Hush Hush boys couldn't talk about their work to their own families, yet they went from receiving the engine to a working prototype in about 6 months. Tight secrecy didn't slow the project down. If anything, the isolation focused it. Lesson 3. A disappointing first version is still worth building. The XP-59A was not a good fighter. Nobody pretended otherwise. But it gave engineers a flying testbed, and within a few years that same lineage produced engines with 4 times the thrust. America didn't invent the jet engine. Britain and Germany did that, independently, before the United States had anything comparable to show for its own efforts. What America did was take a borrowed design, rebuild it under wartime pressure inside a secret factory building, and turn it into an entire industry within a decade. A country that started this race last ended up defining what came after it.